Hello everyone, welcome back to my channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode, where I will show you two approaches starting from the brute force method and to the most optimal solution using binary search. So this is definitely a hard problem. So stay till the end of the video and try to understand everything what I say. And if you still have any doubt, you can ask me in the comment section also. And I will also give a pinned comment where I will explain the steps. Also one thing I would like to ask you to follow my DP playlist also, as I am teaching DP from very basics to advanced. Also, I will be teaching stuffs like Bitmask DP and Digit DP. Okay, so I will suggest you, it will help you in your placement preparation. So definitely follow my playlist. So let's start with Okay, so let's start with the problem statement. We are asked to find the kth smallest product of two sorted arrays. The problem statement is very simple. We are asked to find the kth largest product of two sorted arrays. Okay, these sorted arrays are given in nums1 and nums2. I need to find all the products, and whichever is the kth largest, I need to just find it. So a brute force solution is quite obvious here, right? You need to find all the products, sort them, and find the kth largest. Okay, so a brute force solution is very simple. You are given since you are given two numbers, okay, two arrays, array 1 and array 2. What you can do is that you generate all possible products of array I into array 2 of j. You store them in a vector. You do vector dot pushback. Okay, you do vector dot pushback of this, and you sort the vector. And you return. What you return is simple. You return the kth largest product. So the kth largest product will be present at an index of k minus 1. So you just return it. Okay. So that's quite simple. It should definitely come to your mind, but it is O of n square solution. So definitely we need to try to do something better. You see n square solution will fail here. The length is 5e4. So 5e4. Let's just see to try to see the optimal solution. So first of all, the concept which I will be using here again and again is binary search on answer. Okay, binary search on answer. So if you are following my channel, then you definitely know this because I have solved it using this in some of my previous videos. If you do not know this specific type of binary search, you go to my description. Okay, you go to the description, and the first link which you will get, you try to see the problem and solve it first. Okay, I have clearly explained it, how binary search on answer works. Okay, so even if you do not know it, I will try my best to explain you. Okay, so just bear with me and try to understand. So what you can do is that you are doing binary search on your final answer. So you can see the product of the numbers can be from it's minus 1e5 to 1e5. So what can be the products? If each of the numbers are from minus 1e5 to 1e5, the product can be definitely minus 1e10 to 1e10. Okay, and your answer is going to lie somewhere within this range. Okay, this is the first and foremost observation for binary search. This answer might be lying somewhere in this range. And what is this answer? This answer is nothing but the kth smallest. This is nothing but the kth smallest product of for all this a1, whatever this array a1 I into a2j. Okay, this is the kth smallest one. Okay, so the thing which you need to do, I am trying to propose some statements. So as I have already explained you, I am still explaining again. So how to do that binary search on answer. Okay, so what you will do is that for binary search of answer, I have already given you a template which looks something like this. While L plus 1 less than R, and something like you calculate mid, which is equal to L plus R by 2. Okay, and you have an isGood function. Okay, you have an isGood function also. As I have already explained you what this isGood function means. This means that how you need to shift the pointers is based on M, and maybe you will do L equals to M or R equals to M based on whatever the types is present. Okay, and you just return L or R, whichever is your answer. Okay, so this is how you need to do binary search. So you need to understand here what will be the isGood function. Okay, so if you try to understand now clearly, I am telling you a statement. Okay, if you also don't know this template, just forget about it and try to understand what I am saying. So I am trying to tell you a statement. Let's try to understand. If number of products, I have many products, right? So if the number of products less than equals to, I am searching, let's say this is my L and this is my R, and I am searching within this L and R. Okay, I'm searching within this L and R. This much you understand, right? Within this L and R, I am searching my answer. So I will get somewhere my mid, which will be, let's say at every step I will be doing L plus R by 2. So this will be my mid. So if number of products is less than equal to M, okay, you find all the products which are less than equal to M. If this whole number of products less than equal to M, if this whole thing is less than K, can you tell me what can you deduce from this? What can you deduce from this statement is my question. Try to pause the video and think. What can you deduce from this statement? You can deduce a simple statement that the kth product is definitely greater than M. So how can I say it? Let's try to understand with an example from this, which is the biggest example, this one, right? So let's try to take this example and check. Okay, I have already written the example in my copy. So these are the two numbers which are given. Okay, and -3, -1, 2, 4, 5. So what are the products? I need to arrange in ascending order. Okay, so I am ascending order. Let's say K equal to 4 is given. I need to find the fourth product. Okay, I need to find the fourth product. So you can see first the least one is -5, -2 into 5. So it's -10. Okay, and then it's -8. Then not anything can happen, right? You can't say that I will take in order. Then this becomes the second one. So this is -6. And then this -1 into 5 becomes it. So that's -5. And then this -1 into 4 you have, then 2 into -2 you have, 2 into -2. So you have -4 two times, and so on. Okay, you have some values. So I am verifying nothing but this statement which I made just now. Let's say my mid, I am searching my mid from that -1e10 to 1e10, and I have come to somewhere like -6. Okay, I have come to somewhere like -6. How many numbers are less than or equals to -6? There are three numbers which are less than or equals to -6. This number is less than K. Okay, so this means that the kth number, that is K is here 4, right? So the fourth number is definitely to the right of this, M. M is this -6. I told that how many numbers are less than or equal to M? You told me 3. And then I am telling that if this 3 is less than or equal to this, then fourth or the kth number definitely lies to the right, of M. Okay, so what we need to do? We need to shift my left pointer to M. Okay, as I'm doing binary search, I need to shift my left pointer to M because I know my answer is something here. Okay, so if you already know the basic intuition of binary search, that is only sufficient. You know, L and R and M is there. If my answer lies to the right, I will shift my left pointer to the right. Okay, so if you see, if this statement is true, that if K is less than this thing, then I can shift my left pointer to M. Okay, otherwise I will shift my right pointer to M. So that is very simple. That's very simple. So what I will ask is very simple now. It becomes very simple. Is that from my I will do nothing but something like this. While L plus 1 less than R, okay, I will do my long mid equals to nothing but L plus R by 2. And what I will do now is that I will count, if I will check that if count products, I will write a function. It will count products which will it will return me the number of products which are less than or equal to M. Okay, if my count products of numbers less than equal to M okay, is greater than equal to k. I told about less than equal to k, right? For less than k, if it's less than k, what I was doing, I was shifting my left pointer. Just now I explained you. I will, for less than k, I was shifting my left pointer. So for this, I will shift my right pointer. Okay, I will shift my right pointer. Else, I will shift my left pointer. Okay. I think you easily understood this. I think you easily understood this now. Okay. I will shift my left point, right pointer for this. Okay, and otherwise I will shift my left pointer. I think you already understood this. Okay, I think you already understood this. So what I will do is that at the end I will return r. I will return r. Okay, return r. So now I will do some more things also. You might think that how can we count this product without n square operation. So we will take cases like when this number, I will go through all the x in nums1, and I will take when x is greater than 0, x is equals to 0, or x is less than 0. I will take these three cases and I will again return to this whiteboard. So for now, let's just try to start the coding. Okay. uh, Okay, so let's see, as you get the initial intuition of how we are approaching the binary search and stuff like that. So let me have something. I have already done this has defined long previously. Okay, so what I will do, I will do binary search as I had already told you. So binary search will be on some in this L and R pointer. So for L, I will take -1 E10, but for safety, I will take 1 E10 -1. Okay, I just do this. I have already explained you why I do this. Okay, so +1, I just take for safety. You can take 111 also, right? You can take it. So I just do it. Okay, and then just blindly write this while L +1 is less than R. Okay, LLM is nothing but L plus R by 2. L plus R by 2, and you write the if is good function, right? If is good of this M, you have nums1, you have nums2, and you also have K. If this is true, so what will this count? I'm telling you. Uh, what did I write here? What did I write here? R equals to M or L equals to M. Okay, so that is less than greater than equals to M. Then you do R equals to M. Otherwise, you do L equals to M, and you return R at the end, and you return R at the end. That's all you need to do. Okay, so what will this isGood function return? As I have already explained you again and again, is that uh, number of products greater than or equals to less than or equals to, okay, less than or equals to M. These number of products which are less than or equal to M, if this value is greater than or equal to K here, okay, and this value is less than K. I already told you that if it is less than K, then definitely kth number is greater, and then I need to shift my left pointer. Okay, definitely the kth number is greater and I need to shift my left pointer. So that's correct. Okay, that's correct. You understood this. Okay, so you got it. I think you got it. So all we need to do is count the number of products. Count the number of products. So I will take three cases here when I will go through all the numbers. So first, let me write the good function, right? Uh, this will give me a bool value. Is good function always gives me a bool value. Okay, so if this is nothing but LLM, I have a vector of integer nums1. I have a vector of integer nums2. And what do I have next is I have LLK also. So, so now what would I do? I would need to count, as I have already explained, to count the number of products less than or equal to n. Count number of products less than or equal to m. Now I will utilize the fact that arrays are already sorted. I will utilize the fact that these arrays are already sorted, and you see how I will do it. Okay. If you see, not if, I will keep a count which is 0. Okay, I will keep an integer count, not integer count, it can be L count, right? It has to be LL count because I will compare it with K, and K is of the order of long. So this needs to be long count. And I will go through what for auto x. I will go through all the element x of nums1. I'm going through all the elements x of nums1, and I will take three cases. If x is greater than 0, okay, positive values. Else if x is equals to 0, or this is for negative values. Okay, so you easily understood this. Is that okay? So there's a bracket issue. Let me just correct it. Uh, so I guess you have it. This is for positive numbers. Okay. This is for negative numbers, not negative 0, and this is for positive numbers. So what I need to, this is for negative. Okay. So what I need to do is count the number of products less than or equal to m. Okay. Now, what if x is 0? Whatever thing I will multiply, what I need to multiply, I need to multiply nums I minus nums I into j, right? So I am doing nothing but nums 2 into j. I need to check this product. To check this product is less than or equal to m or not. I need to check this product is less than or equal to m or not. Okay. So uh, let me tell you something. For this, if it is 0, if x is 0, this product is always 0. And if m is greater than or equal to 0, then I need to add all values of this number. So this x gets multiplied with nums of j. So it means that it gets multiplied with all the elements of nums. So I will do nothing but, you see, 0 is 0, get multiplied by the first element of nums2. Then it will get multiplied by all the elements. Okay. And it will always give me something which is 0. All this I need to add in my count. All this I need to add in my count only if m is greater than or equals to 0. Okay, if m is greater than or equals to 0. So if m is greater than or equals to 0, what I do count plus equals to nums2 dot size, because all the elements, all of these products gives me 0, and my m is greater than or equals to 0. So all of these products are definitely less than or equals to m. I am returning this count of products less than or equal to m. So I need to add all these elements. So 0 was the easiest case. Okay, 0 was the easiest case. What I need to do here? You try to think. I need to find count of uh, all products, x into nums2 of j less than or equals to m. Okay, count of all the products m is less than or equal to j. Okay, when x is positive and when x is negative. So I have taken one example, and I will try to make you understand using this example how I will find this. Okay, I will use the fact again binary search. You can try this on your own. This one is not difficult. It's very easy to understand also. So let me take this. Let's say this is the products. I have the products list which I writing directly. Okay. So somehow you understand that this is the products list. Okay. So I have written it in my copy also. Just I am looking and just okay. Took it from my copy. So I have, let's say, x. Okay. X as something to be -2. Okay. So the product and x has to be 2. I will take two things. Okay. And the product, let's say 8 is my target mid value. Okay. My mid value, m value, is nothing but 8. So I need to search this. When will this product be 8? Given one of my number is this. Okay. Given one of my number is this. Okay. So this is not the product array. First of all, this is nums2 array, which I'm iterating. Okay. Nums2 array. So I will multiply everything. I will multiply. So let's see. Let's see what will happen if my thing is positive. Okay. So if x is positive, it's -10, it's -8, it's -6, it's -2, it's 4, it's 6, it's 8, it's 10, it's 14. So I need to count the number of elements less than or equal to 8. Remember, less than or equal to m. So these are all the numbers which are less than or equals to m, and these are greater. So easily you can understand that I will do a binary search here also. I will start from L. Let's say -1, and R, let's say n. I will find the index. As I will reach here, I will stop. I will reach here, I will stop. Okay. This will be of the binary search of type 11100, as you already know this. Okay. So as I will get here, I will stop. And this my L will be lying here. My L will be lying here. And I will return L plus 1 because that is the index. That is the index length, right? I mean, this is -1 based indexing I am doing. Okay, -1, not that zero based indexing. For zero based indexing, the number of elements, let's say, what is the index number? It's 0, 1, 2. This is basic, right? You know it. This six index means there are 7 elements. So if L index, it means that there are L plus 1 elements. I will return L plus 1. So for the positive case, you easily understand that as we multiply these numbers, we get, I need to find the number of elements which are less than or equal to m. I will find that using another binary search. Okay, I will find that using another binary search. So let me write a function. It will just add in my count positive product. Okay, count positive products. Okay, count positive products. What it will take? It will take x. It will take nums2. It will take m, right? And what it will do is again it's simple. It will give you some count. Okay, it will give you some count. So count positive product, and that will give me nothing but llx, and I have this vector integer nums2, and also I have this LLM. Okay, so what you need to do, count positive products. So to do binary search here also, right, you need to find the indices. So you do L equals to -1, R equals to n. As I have told you, use the same thing again and again, exact same thing, L plus 1 less than R. And this I will take as J. Okay, I will not take as made, I will take as J. This made value only. This made value only. I am taking it as J. Okay. Thing is that if x into nums of J is less than or equals to m, if it's less than or equals to m, okay, what you do is that you do L equals to m. Okay, L equals to J. Else R equals to J. You shift the left pointer or you shift the right pointer. I'm doing this simple binary search. Okay, I guess you already know this already. Okay, so it's nothing but if this criteria is valid, if this condition is getting valid, if it's less than or equals to none, that means I have a 1. It is giving, it's a Boolean function, right? L less than or equal to is a Boolean function, so it's giving me 1 every time it is less than or equal to J. So it's giving me 1 here, 1 here, 1 here, output 1 here, and it gives me 0 here. It's a Boolean function, so it starts giving me 0 here. So I will need to find this one. I need to find this maximal one. So if this mid value is something here, if this mid value is something here, I need to shift my L equals to mid. Okay, I need to shift my L equals to mid, otherwise I will shift my R equals to mid. And what I do is very simple, very easy. I just return L plus 1. I just return L plus 1. You already understood why I am returning L plus 1, all these, right? Now I will try to count the negative products. Okay, the same thing I will just copy paste, and I will again return to the explanation of whiteboard of what I should do. Okay, now and what I should return also. So let me try to understand and make you understand. Okay, so I told all these is for positive integers, right? I told all these were for positive integers. So let me try to select this whole thing and just delete it. You already understood that, right? For the positive case. For the negative case, what will I do? It's very simple, very easy. Negative case also. The x is -2. Okay, so now I'm multiplying -2, and I need the same thing with number products which is less than equal to this. Okay, so this is nothing but 10. This is nothing but 8. This is nothing but 6. You see, minus into minus is positive, so it's getting positive, and this will all be getting negative. -10, -14. So what can you understand from this? What can you understand from this? It's very interesting. See, you need all the numbers which are less than or equals to 8. Earlier, it was arranged in an ascending order, right? So you needed something, this was 8, and you needed everything which is less than or equal to 8. Here, everything which is less than or equal to 8 is in the suffix portion of the array. So you can perform a binary search here also in the exact same manner, but the array is reversed. So you just need to reverse your criteria. And when your pointer reaches here, what you need to do is very simple. You just return n minus that index. Okay, you see, you try to visualize whichever is the elements are greater. You try to treat them as L and treat them as R. So this will be marked as R, and this index you need to find all such elements, right? So this is how many elements are there. First of all, count the number of elements: 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 elements are there. Okay, my what is the value of this R? 1. Okay, if I subtract my 9 from 1, I will get 8. That is the total number of elements present here. So how do I write this negative product binary search? It's the exact same manner. I'm just copy pasting this. Okay, I'm just copy pasting this function. I am doing nothing but changing this positive to negative, and this thing I am just changing. That if x is greater than m, because the array is now reversed, and now if it's greater than m, we are treating this greater value as an L pointer, and R pointer is the thing which is less. So I have this R, and my answer is nothing but n minus R. What is this n? What is this n? Okay, I did not initialize this n. So you see, there's a mistake. I did not initialize this n. This is nothing but nums2 of size. Okay, so I just need to plug in my laptop. Okay, so this n is nothing but my nums2 dot size, which I will copy here also. Okay, so you see, now everything is very well. If only this isGood function, if you realize, what does this function returns? Number of products greater than or equal to k. So what is the number of products? Count. We have the count, whether it is greater than or equal to k or not. I just need to return that. Okay, I'll return this, nothing else. It's very simple. Okay, so if you try to run this and check, what will happen? Did I do some error or something like that? Expected member name after this count is member name. What do they mean by member? Can I in after declaring specifiers? Okay, so this bracket is just different. So let's try to run this. I think there will be some errors. I just want to show you the errors. Okay, that's why just I'm submitting it, because it's very essential for solving any problems. So you see, okay, it's accepted also. So when I was solving first, I did some errors, right? So what are the errors? I will just explain you. When you are multiplying this x, make sure this x is LL. You are passing this x as LL. That's very important, because this is a long getting compared with a long. It will give you error. And another thing which problem of binary search, I mean, it's not very simple. I will agree that if you're solving for the first time, it's very difficult to get with this idea that 3 times you need to apply this binary search. But if you know, and if you once you structure out everything, write it in your copy, that how is everything, I mean, if you structure well your approach and you just approach it with what you did, definitely you will get something which is accepted. Okay, so this was definitely a hard problem for today, but I hope your day is going to be really easy. Thank you so much. And if you did not understand any portion of the code, definitely ask me in the comment section. Thank you so much.